Hello. So we're gonna start chapter 6, vertical relations. So in this chapter, we try to understand the vertical relations between manufacturer, retailer, and consumers, right? So there's a step. First, manufacturer manufactures the product and it goes to second guy, retailer. And then retailer sells it to the end consumer of consumer, right? So there's a steps, and we're gonna look at the vertical relationship among these three guys, and especially the strategic interaction and relationship between the manufacturer and retailer. Okay, so let's look at the goal of this chapter. The goal of this chapter is to learn how to solve the equilibrium in the separation case and integration case. Understand the comparison result between these two cases. So we're going to look two cases, separation and integration. So what do we mean by the separation is we have manufacturer, retailer, not same. And we have the integration case, manufacturer, retailer, the same guy. Okay, and two, to learn the franchise and profit sharing contract between the manufacturer and the retailers. So learn how to solve the equilibrium with retailers' competition. And three, to understand why the reality sometimes it is difficult to induce good sales effort from the retailers and how to solve those problems in reality. Okay, so let's look part one. Benchmark model, vertical separation. So we're going to look where manufacturer is not retailer. Okay, so let's look at it. Numerical example. Suppose that a car dealer has a local monopoly in selling Toyota. So we have a monopoly retailer, right? Dealer is a retailer. And it pays the wholesale price W to Toyota for each car that it sells and charges each consumer the retail price P. The demand equation for the dealer in the retail market is P equals to 50 minus Q, where price is the unit of thousand of dollars. The marginal cost of Toyota is $10. So now we have a little mixed explanation about the price and the cost. So we have to separate which one belongs to which, right? First, we have manufacturer, right? We have manufacturer, Toyota, and we have retail dealer, right? So what is the cost for the Toyota? The marginal cost for Toyota is 10. So marginal cost for Toyota is 10. And do we have the marginal cost for dealer? Yes, we do. Here we have it pays, dealer pays the wholesale price W to Toyota for each car that it sells. The marginal cost for retailer is W, right? So what is the price for Toyota? The price for Toyota is they're not selling directly to consumer, right? There is the first step, there's the second step. So they sell to dealer at the price of W, right? And the price for dealer is the final price P, right? And what we have an equation for the retail market, right? So we have the demand curve in retail market equals to P equal 50 minus Q, right? So we have dealer side, we have Toyota manufacturer side. Okay, we have to separate first. All right, so let's move on. So preliminary analysis. Here we have two important players, manufacturer, Toyota, whose strategy is the wholesale price, W, and retailer, the car dealer, whose strategy is the retail price, P. Moreover, they move in the sequence with the manufacturer deciding the wholesale price W first. So we need to use the backward induction. Why? Because we only have the demand curve in the dealer side, right? We don't have the demand curve for the Toyota, right? We're gonna sort this first and move on to Toyota next. So then we go back to solve the manufacturer's problem. Eventually putting their respect optimal strategies together, we can solve the Nash equilibrium of prices, right? Note here the retailer's marginal cost is not $10, but the wholesale price, W, right? Someone's price becomes the other's marginal cost, okay? So let's go to the whiteboard to make it a little clear, right? So we have a, I'm gonna make it a little smaller. We have a sequential relation, or we have the vertical relationship between or among manufacturer, retailer, right? Manufacturer, retailer, and consumer, right? So what do we see is from the first stage to the third, right? If as product moves from the first guy to the third guy, right? Price increases, right? And we're gonna look at that. So where we're gonna look at the marginal cost for each guy. So marginal cost for the manufacturer, marginal cost for retailer, and marginal cost for consumer, okay? So what is the marginal cost for the manufacturer? We have seen it is marginal cost of the manufacturer, just gonna write the number, equals to $10, right? So what happens from 10 to go to retailer, right? This is the MC of M. So to get to MC of R, right, we're going one step, right? So we're gonna get what? We're gonna plus some alpha on the marginal cost of manufacture, right? So that 10 plus alpha becomes what? The price of manufacture, right? Price of the manufacturer, and it becomes the marginal cost of the retailer, W, okay? And what about the second step from here to there, right? W, from the W, the marginal cost of the retailer, they want to charge some more to make some profit, right? Positive profit. And it becomes P, right? So W is 10 plus alpha, and P is W plus beta, right? So what we're seeing is they are creating some profit, right? Profit of the manufacturer, non-negative, right? And we want to set the profit of the retailer non-negative by putting some price on top of the marginal cost. Let's look back. So solving the Nash equilibrium. So using the backward induction, we start with the retailer's problem, and given the retailer's marginal cost, the wholesale price, and we get the marginal cost for the retailer and get the optimal Q related to W, and we're gonna put this back to the price to get the W, right? And go back to the solve to the manufacturer's problem, and from the retail's optimal condition we get the demand curve for the manufacturer, and with this we can solve the Nash equilibrium for both retailers and manufacturers price, right? So we're gonna go to the whiteboard to see it more in detail. Okay. All right, so I'm gonna write down one more time. So for the whole manufacturer, we have the marginal cost of the M equal to $10, and their price of the manufacturer, right, will be same as W, right? So W is what? The demand curve for manufacturer. And we have the retailer, their MC of R retailer equals to W, and their price equal to price, and price is given by 50 minus Q, right? So we start from here, right? So since P equals to 50 minus Q, the total revenue for the retailer is P times Q. Sorry about the siren. I have the fire department near. So P times Q becomes the total revenue for the retailer, right? And that is what? 50 minus Q times Q. And we get the marginal revenue for the retailer equals to 50 partial derivative of 50 Q negative Q square, right? With Q, and we get 50 minus 2Q. And that equals to what? Marginal cost of W. Right? So we got the demand curve for the producers. So we got the what? Marginal cost of the retailer W equals to 50 minus 2Q, right? So we can have Q equals to 25 minus 0.5 W, right? So if we put back to the price, right? Price of the retailer equals to 50 minus Q, and we're gonna substitute with 25 minus 0.5 W, so 50 minus 0.5 50 minus 25 minus 0.5 W becomes 25 plus 0.5 W, right? That is the P. So the retail price will be decided with W, right? And now we go back to the marginal cost total revenue of manufacturer. So here they have W times Q, right? And W, we have 50 minus 2Q, and we can get 50 minus 2Q times Q is total revenue for the manufacturer, so we can get the marginal revenue for the manufacturer equals to what? Derivative of 50Q negative 2Q square with Q, right? So we get 50 minus 4Q. Right? So marginal revenue for the manufacturer equals to 50 minus 4Q. But do we know Q? No, we have the Q of information of 25 minus 0.5 W, right? So we can get the marginal is using this marginal revenue of the manufacturer, we can get W. So how we get it? This is monopoly, right? So the marginal revenue of the manufacturer should equal to the marginal cost of the manufacturer, right? So what we got was 50 minus 4Q, right? And marginal cost was $10. And we want to substitute that Q with W related, right? So minus 4 and 25 minus 0.5 W, right? Equals to 10. So we have what? 50 negative 100 plus 2W equals to 10. So 2W equals to 50, 60, and we got W equals to 30, right? So the what? The optimal price for the manufacturer is 30. Then what happened? We can get the P, right? P was what? P was 25 plus 0.5 W, right? So we get 25 plus 15, so we get the price of 40 for the retailer. So we can get what? The Nash equilibrium for the price of the manufacturer star and price of the retailer star, right? That goes to 30 and 40, right? And that is equal to W and P. Okay? All right, so going back to the slide. Okay. So now we can get the profit for manufacturer and retailer, and also we can get the consumer surplus, and after all we can get what? The social welfare. Okay, so let's look at it in the whiteboard again. So what we have is, what we want to know is profit, right? So we want to know the profit for manufacturer and profit for retailer, so we can get the aggregate profit in the market. And also we want to know the consumer surplus, right? And together we can get the social welfare, right? So first start with the manufacturer side. So what is the profit for the manufacturer? Is the price for the manufacturer W negative what their marginal cost of $10 times the quantity, right? And we can get the profit for the retailer is P negative W times Q, right? So we can just plug the number in. What is W? W is 30 and the marginal cost was 10. And what is the Q? Q is, let me see, Q is, I think we didn't calculate it before, so I'm gonna write it in red. So Q equals to 25 minus 0.5 W, right? So 25 negative 0.5 of 30, so it's 15, right? So we get the Q of 10, okay. So Q equals to 10. So we multiply by 10 and get what? 20, right? 20, 10, so 200 profit for manufacturer. What about the retailer? The retailing price is $40, right? And the W is 30, and we get 10 of the quantities, so we get 100 profit for the retailer. What about the consumer surplus? What was the demand curve? Demand curve was 50 minus Q, right? So if we draw it right here, we have the 50 to start with P on the vertical and Q on the horizontal, and it goes down with the degree of 1, right? And we have the equilibrium quantity at 10, right? And equilibrium price at 40, and we have 30 for the cost of retailer, and we have 10 for the marginal cost of the manufacturer. So we have now three parts, right? We have the triangle for consumer surplus. We have the first square, right? For who? For retailer. And we got the last box for the manufacturer. And we got what? This equals 200, that equals to 200. And now we have to calculate the triangle side, right? So look at it with the different color. So we have the triangle 50, 40, 0, 10. So we have 10 times 10 to the half, and we get 50, right? So we got the consumer surplus equals to 50. So we have 200, 100, and 50. So all together we get the social welfare equals to 350. Okay, so let's go back. Okay. part 2, vertical integration case and its comparison with the separation case. So what is integration? So in the above example, the retailer and the manufacturer work separately and independently, right? So the manufacturer was a different guy from the retailer, but sometimes the retailer may integrate with the manufacturer and work together as the same company, where the manufacturer is at the same time the retailer. For instance, ExxonMobil not only controls the production of the oil and gas, but also has its own gas station. Another example could be the Apple, and this is the case for the vertical integration. And now we want to solve the equilibrium in the integration case, where manufacturer is at the same time the retailer. And let us still use the same numerical example in part 1, right? So now we assume Toyota has both the ownership of the car dealer and they integrate together, right? So now it goes right from manufacturer to consumer directly. There is no middle guy, right? So what happens? Now we can see it's no longer vertical relationship, right? This is direct. So there will be it's only the monopolies problem. So solving the equilibrium in the integration case, actually the problem is much easier to solve. For now, the integrated firm work as a joint monopolist for the consumer. So it's just the monopolies problem that we solve in the chapter 2, right? So we set the marginal revenue equals to marginal cost. There is no middle price. So marginal revenue, right? And they take the price. So now what happened is, before we have the price that is not equal to W, right? And the price was equal to 50 minus Q, right? The example was like that. And now, since we're the retailer and the manufacturer is the same guy, W is at the same time P, so we can get W equals to 50 minus Q. So our demand curve, the manufacturer is given as the retailer's demand curve. So the total profit for the integrated firm is the profit, right? What do we have this? Plus the retailer's profit, but we have 0. We don't have the retailer, right? So the profit of the manufacturer is at the same time profit of the monopolist, and he can get 400, not 300. And the consumer surplus is now increased. Why? Because before we had only 10, right? And there's a 40, there's 30, there's 10. So we have the first guy, second guy, third guy, right? But now it became going down at the same curve, but the Q is increased to 30, right? So the triangle became bigger, and the square, right? Square for the manufacturer became bigger also, right? So we see more profit and more consumer surplus. So in the end, we see bigger social welfare. So why don't we do this, right? So in the terms of both consumers and firms, we find that the integration case is much better than the separation case. Total profit is bigger, right? Consumer surplus is bigger. So the simple and rough explanation goes as follows. So for consumers, the integration kills the middleman, right? The retailer. And for firms, the integration removes the conflict of interest between the manufacturer and retailer. So it's a win-win, right? So it's much better than the separation case, but in reality, we find actually the separation is more common, right? In the following part, we'll introduce 3 practical methods that is used in the vertical separation, right? And why we have the separation is first, I can come with the 2 reasons. One is if just look at the ExxonMobil, right? If they own 5 gas stations, it's easy to control, right? But they have thousands, 3,000 of gas stations to control. Then what happened is it's hard to control for all of these retailing shops, right? the quality, there should be some quality issues, there should be like price differences, although they are same companies, right? Blah 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 blah, right? So it's hard to control when the size of the manufacturer becomes large, right? And the second is what happens here. We have how many guys here? We have 1, 2, 3 guys, and we only have 1, 2 guys there. So if we're looking at the whole population, right? This is like we're sharing the pie with smaller slices, right? And we're having like a bigger slice for 2 guys or smaller slices for 3 guys, right? So it's about, could be related to job opportunities, right? Okay, so let's move on and look at the real example of how the theoretical relationship works. So we have retailer competition, franchise contract, and profit sharing contract, right? So if we have, let's say we have, I don't know if you guys know it, but like, oh no, yeah, I have good. So let's say we own a Whole Food. I don't know if they are really doing the retail thing, but let's assume the Whole Food is a manufacturer, a retailing store that we own and is provided with some manufacturer, right? So what happened is if the Whole Food is not really, I don't think it's a good example of the Whole Food. I'm going to go for local supermarkets, okay? Because Whole Food is more like the franchise or the profit sharing, right? So local supermarkets, right? Let's assume there is a supermarket 1 and supermarket 2. They are both good qualities, right? And they're provided with the same manufacturers. So their marginal cost is same. Then what happened is to attract more consumer to their supermarket, they might go what? Lower price than your competitor. So what is happening is we're looking at, once again, the Bertrand competition is happening right here, right? So if we have multiple retailer provided by the same manufacturer at the same location, right? Same local supermarkets provided by the same manufacturer, then they might occur the Bertrand competition. Then what happened is they end up getting zero profit, and only the manufacturer can get some profit, right? So let's look at it. So retailer competition, we modify the original separation example by assuming now Toyota has 2 retailers engaging in the one period Bertrand competition. So let us solve with new model with the retailers competition. So answer is to use the backward induction again. We start from the retailer's problem since the 2 retailers have identical marginal cost, right? MC equals MC1 equals to MC2 equals to W. In the Bertrand equilibrium, what we do is set the price equals to the marginal cost, right? So P1 and P2 should equal to W. And they will both get the zero profit. And go back to the manufacturer's problem, since now the wholesale price W equals to the retailer price P, we can use the same what? Demand curve to solve these. And and we can get MR equals to MC and get the what quantity once again, and we get the W once again. And the 2 retailers' profit is 0 and the manufacturer's profit is 400, right? So what happened is same as monopolist problem. So what happened was, even though we have first, second, and third guy, right? We have the manufacturer, retailer, and consumer. But since there are 2 retailers, they compete with each other, ending up zero profit. That means we wanted to set what? The manufacturer, retailer, consumer, marginal cost of the manufacturer, retailer, consumer, right? From marginal cost to plus alpha becomes the W, and plus alpha becomes P, right? So that's how they make the non-zero profit. But now since they are competing with each other, there is no alpha, right? So that's why the retailers, both of the retailer ending up giving zero profit. So what we're seeing is, oh, it's like we skip the retailer, right? That's why we're seeing the same monopolist solution. Okay, so let's look at the second reality problem of the franchise contract. Okay, so usually the franchise contract contains two parts. One is to set the W equals to the marginal cost of the manufacturer, right? They're not charging plus alpha. There's no plus alpha on the W. And so that this payment can fully compensate the production cost and the franchise fee F, right? So the manufacturer is profiting from franchise fee, not the what? The price difference between the wholesale price and the marginal cost. So two things to note. One, the franchise fee F is a fixed cost for the retailer. And two, now the manufacturer's profit is, this part is what? Zero, right? Plus the franchise fee becomes the profit of the manufacturer, so it ends up F, right? And the what? Profit of the retailer will be their total revenue negative the franchise fee. Okay, so a numerical example. If the requirement is that the profit of the manufacturer, right, is same as 2 times the profit of the retailer, right? So if this is the requirement and the total profit is the same as the integration case, what will be the franchise contract, right? So now we are just thinking about how to share this profit. So we know in two-part tariff contract, the total profit is same as the one in the integration case. So the total profit should equals to 400, right? Moreover, the manufacturer profit is franchise fee F, and the retailer profit is 400 minus F. So to make the profit of the manufacturer equals to the two, right, double of the profit of retailer, we need to set what? The profit of the manufacturer equals to F, and profit of the retailer equals to 400 minus F to have, right, total profit equals to 400, right? And now we want this, right? This is, right, equals to 2 times that guy, right? So we're just setting 2 times what what profit of the retailer, 400 minus F equals to the profit of the manufacturer, F, right? And solving this, we can get the franchise fee of 800 over 3. So the two-part tariff contract is that the wholesale price equals to the marginal cost, and we get the franchise fee, okay? And let's look at the last example. Profit sharing contract. Usually the profit sharing contract contains 2 parts. W equals to the marginal cost, just like our franchise, right? W equals to MC, and they are just sharing the total profit, right? And how to share the total profit between the manufacturer and the retailer, and it usually takes the form of alpha to 1 minus alpha, right? So what we're seeing is if we set alpha plus 1 minus alpha, what is that? Profit for the manufacturer, profit for the retailer, so we get the total profit. And what we get is what? Cancels and 1, right? So we're having 100% of the profit divided into alpha portion and 1 minus alpha portion. Okay, so it's setting the percentage of the total profit enjoyed by the manufacturer and the other side by the retailer. So numerical example, if the requirement is same as what? The profit of the manufacturer should equal to 2 times the profit of the retailer, then we'll use what? We have pi manufacturer is 2 pi retailer, so we can have what? The total profit equals to 2 retailer profit plus retailer profit, right? So here we have manufacturer profit, and here we have retailer profit, and in the sum we have 3 times the retailer profit, right? So the 100% is same as 3 times the retailer profit. So what we get is the retailer profit is 100 over 3, or 3.3%, and the other belongs to the manufacturer, right? So we can have like double the size. Okay, so let's move on to the last one. So part 4, retailer's sales effort. So in the previous part, the retailer is our models played a quite passive role, so acting only as a middleman, right? So he got right price of W and put some additional fee to get price, that was it, right? So charge or not charge, right? They're charged if there is no competitor, and if there is some competitor, they don't even charge the profit for their selves, right? So they're very passive, but in reality the retailer is very important, right? So for its good sales effort, such as providing good customer service, running successful advertising and marketing campaign, and gathering detailed information about consumer demand, and could greatly boost the sales and the profit, right? It's not just given by the demand curve, but they can make the demand curve go wider, right? From here to there. Let me for one more time. So let's assume we have that kind of demand curve, right? So there is consumer, we have the manufacturer, we have the retail, and we have consumer profit, right? And if we can make the line, right, goes to that, if we can move the demand curve, what happened is we're actually making actually making the retailer's profit larger, at the same time making the manufacturer's profit larger, and at the same time making the consumer surplus larger, right? So by the retailer's good sales effort, everybody can be happier, right? So however, it is actually difficult to induce the good sales effort from the retailers, and these are 2 reasons. First, competition between the retailers, right? So severe retail competition drives down the retail price, thus reducing the incentive to provide good sales effort. In reality, sometimes manufacturer has to fix or put a price floor for the retail price in the contract to reduce the competition, and it is called by the resale price maintenance. So first thing is competition between the retailers. So we have the what? 1 time 4 word trend competition is happening, right? So what happened is if they don't agree at some price level, they have to go back to the marginal cost of W, right? So they are losing money actually by promoting with lower prices. And since sometimes it goes like hard, right? So marginal cost, the price equals to marginal cost, or marginal price is lower than the marginal cost to make the market dominated, right? And they can actually hurt the manufacturer at the same time. So sometimes they put some price floor, right? Floor to get the contract, reduce the competition, and thus and positive externality between the retailers. So sometimes my promotion actually doesn't benefits me, but the others, right? So I have a little example of assuming, right? So assume you have you own an Apple computer, right? Apple. I'll just say Apple, right? So you own Apple, right? And now you came up with new MacBook, right? So you promoted the MacBook for the very good advertising mechanism, right? Oh, promoting, oh, this is a good feature for the MacBook. This is a high definition, the speed is faster, blah, 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 right? So you promoted and the advertisement costs a lot of money, right? Cost goes up, right? But what happened was, oh, people thought, oh, your advertisement is really good, right? So MacBooks seem really good, but what in reality is too pricey for me, right? So I'm gonna go for some cheaper laptop, right? So this cheaper laptop that didn't even promote it, right? They didn't make any advertise, but from the Apple, they're benefiting, and MacBook actually doesn't really boost their sales, right? So this is a possible externality to the cheaper laptop company, but is what not a good option for the MacBook, right? So the goodwill of promoting this MacBook is now I don't want to, right? So this is why the promotion or retailer's effort is less likely to happen. So thus none can fully enjoy the return of his sales effort, which reduces retailer's incentive to make the good effort. So in reality, sometimes the manufacturer has to separate the retailers by establishing the exclusive territory for each one of them. So like in Queens area, right? In Queens area, we want one in Flushing, right? Only one in Flushing. And we want one in Jamaica, right? We want one in Astoria. We want one in Sunnyside, right? So it's allocated to make what? The competition less harsh. So once each retailer is separated from each others, they can enjoy its own exclusive sales territory, and externality between them is removed. So it can boost the retailer's sales effort. Okay, so we're gonna stop here and then come back with chapter 7. Good night.